Welcome back. We are now on worksheet 8B. In the next preview assignment and in the next class, you're going to need to be able to explain the difference between proportional and linear relationships. We're going to start with the slope of the line between 2 points. It is common to know the x and y coordinates of 2 points in the plane and to want to find a slope of that line that connects those 2 points. Here's a formula. You need to write this down, memorize it, put it in your glossary, flashcards, something. You need to memorize this formula. And in this formula, the coordinates of the points are, as you see here and here, x sub 1, comma, y sub 1, and x sub 2 and y sub 2. Question 1. Subscripts are letters or numbers written below the line of the text, like these that you see right here. The little 2 and the little 1. Why is it necessary to use variables with subscripts in the slope formula? If you haven't already hit pause and answered this question, do click pause, write down an answer for this question, and then come back and let's work through this together. So a possible answer to question 1 is that since there are 2 points, there are 2 different xy values and 2 different y values. So we need a way to distinguish the x's and the y's. Again, this is a good time to hit pause, complete all of question 2, and then come back and we can work through this together. And while you're gone, if you're having difficulty, there is a resource in your My Math Lab in-class binder or inside My Math Lab, the actual electronic piece, and there is a slope resource. I would encourage you to get that resource, look over the resource if you're having difficulties calculating slope. Go ahead and do all of 2, come back and we'll work through it together. It does say to use the formula to find the slope of the line that connects the following pairs of points. Round your answers to the nearest tenth when necessary. I highly, highly, highly encourage you to always write down the complete slope formula. I highly, highly, highly encourage you to label your points. It does not matter who you label as the x1, y1 or who you label as the x2, y2. You just can't switch them around and call like the first one x1, y2. It has to be 1, 1 or 2, 2 or 2, 2 and 1, 1. So I highly, highly, highly encourage you to label your points. I highly, highly, highly encourage you to write down the formula so that you can then start plugging in pieces. Like y sub 2 is 12. The formula says write down a minus. Y sub 1 is a 2, and then there's a division. X sub 2 is 6. The formula has a minus, and x sub 1 is a 1. You treat the numerator and the denominator like they are surrounded by parentheses. In other words, you do the numerator, and then you do the denominator before you put them together. Like in this case, what is 10 divided by 5? Well, a slope you can write like this, or you can write it like this. I'll be pushing us to write information like this because of what slopes will mean, like 2 miles for every 1 gallon that you use, etc. We're going to move on to the rest of the parts. If you were having trouble with part A, but now you feel better about it, hit pause and complete B, C, D, and E by yourself, and then come back and double check with me. I'm going to go through these fairly quickly. I'm going to be very predictable that I am just going to label x1, y1, x2, y2. I'm going to write down my slope formula every time. It's going to help me to memorize it and help me to cut out on those stupid mistakes. So here's y2, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'll do what's in the numerator first. I'll do what's in the denominator, second. Excuse me. And then I get this as an answer, but probably this is what you're going to want to leave it as, but there is value in seeing either of them. Both are correct. Part C, here we go. I'm going to write down the formula. I'm going to label each one of the parts of our 2 points. And then I'm going to take y sub 2 minus y sub 1, put it over x sub 2 minus x sub 1. I'll simplify my numerator, then simplify my denominator. And this one, I'm actually going to go all the way to 0. No stopping at 0/3. Finally, we have one more to calculate on my page. You have some more. I'll write these below, but I'm going to go ahead and always label my x1, y1, x2, y2. I'll always write my slope down. Keeps it fresh in my brain and also helps to keep me more accurate. I'll put down my y sub 2. The formula has a minus. My y sub 1. This is my x sub 2. The formula has a minus. And then my x sub 1. I'm going to do the numerators first. And then I'm going to do the denominators next. And this one's not coming out simple or cute like the 2/1 happened in our part A. So I'm going to go ahead and divide 17 by 3, and I'm getting -5 point and a whole bunch of 6s. And the directions said to the nearest tenth, so if there's a bunch of 6s, I'll need to go ahead and round that to 5.7. I'm going to keep going with part E. And on part E, again, I'm going to label x1, y1, x2, y2. Again, I'm going to start out with my formula. And then I'll plug in the points. This is my y sub 2. The formula has a minus. My y sub 1 is a -3. My x sub 2 is a 2, and the formula has a minus. And my x sub 1 is a 6. Our integer rules tell us that we're going to add the opposite here. And once we do so, we're going to end up with a -4 in the numerator and a -4 in the denominator. That'll reduce to 1/1 or simply 1. This is probably the best answer, but you're going to see later why there's value in leaving a slope in 2 parts, a numerator and a denominator. Both are great answers. Part F, does the order of the points matter in the formula? Excuse me on the coughing. I don't know if you have allergy stuff where you are, but it is where I am. So when it says, does the order of the points in the formula matter? I'm going to say, no, it doesn't, but then yes, it does. So I'm going to go back up here to part E, and I'm going to relabel this one. I'm going to relabel it that this is x1, y1, and that this is x2, y2. And I'm going to calculate it again. So the formula is the same, but I have labeled not as x1, y1. I now have it as x2, y2. And not as x2, y2, but now as x1, y1. So when I go plug in my numbers, my new y2 is now the -3, and the formula still has a minus, and my y sub 1 is the -7. My x sub 2 is 6. The formula says throw in a minus, and then the x sub 1 is a 2. My rules for integers, to subtract, I add the opposite. And so my numerator is a 4 over a 4, otherwise known as 1/1, or 1. And you'll notice we get the same answer. So to answer the question, does the order of the points matter? No, as long as you keep your 2's with the same point or your 1's with the same point. What does matter is if you come along and decide you want to call this one x1 and y2, and this one x2 and y1. I'm going to put a big old, oh no, on that. Do not crisscross, or whatever you want to call it, your x1 and your y2s. No, 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 no. But it doesn't matter if you call both of these the 1 and both of these the 2, or vice versa. Continuing on with question 3, 4, and 4. When you're looking at question 3, if you haven't already done it by yourself, you need to hit pause and do this one by yourself, maybe 3 and 4, and then come back and let's talk through it together. So looking at question 3, sometimes we can identify an error we make after completing the slope calculation. And if we know what we're doing, we can modify the answer without having to redo the entire computation. There are 2 common errors with using the slope formula that can be very easily fixed. The first one is, if you calculate the slope between 2 points and get an answer of 1/2, but the line looks too steep for this slope, you realize you accidentally mixed up the x's and y's. How could you fix your answer? Well, if it doesn't seem right, like it's a lot too steep for what you're looking at, then you've mixed up your x's and y's. If it was the change in y over the change in x, and you've mixed them up, you have 1/2, well then correct that and make it 2/1. A second common mistake is in part B. You calculate the slope between 2 points and you get an answer of -3. But the line is pointing like this, and that should be something that's positive, and you realize you have correctly calculated this, but you accidentally calculated this backwards in the denominator. See how you had the 2 minus the 1, and here it's the 1 minus 2? So to fix your answer without starting over, if it's not supposed to be the -3, which would indicate a downward slope, then all you need to do is to change it to its opposite, make it a positive. Here's the table for question 4. The following table gives distances traveled in different time intervals by a Dodge Durango. Here's the time in seconds and the distance in yards. I'm looking at part A, and it says we will use time for our x variable and distance for our y variable. So it helps my brain to actually see that they're saying we're going to use time for our x variable and distance for our y variable. And most often, very often, we can't say always, time is going to be what ends up on your x-axis, and your time is independent, and then it generates the dependent distance. Part A asks us to write the points in the first, and fourth columns, and it wants us to write them as ordered pairs. So this first one would be written as, oh wait, hang on, I need to do one more thing. This is my x, this is our time, and this is our y. If that's the case, our first coordinate would be 20, 145, and our fourth column coordinate would be 35, 250. Part B asks us to calculate the slope using these points in the first and fourth columns and leave your answer as a reduced fraction or integer with the appropriate units. I'm going to try to stay on this page, write my formula, which is the change in y over the change in x. I'm going to label x1, y1, x2, y2. I'm going to fill in the pieces and parts, like 250 minus 145, 35 minus 20, and having done so, I'm getting 105 over 15. I'm going to go ahead and double check the numerator, and we've got the 105. I'm going to divide it by 15, and it's coming out as 7. Remember a while ago I said you can leave it one way or the other, and both are very acceptable, but I'm going to lean us or push us to do this one. If my y's are what's in the numerator, then I have 7 yards for every 1 second. And in this case, we could say 7 yards per second. but it's asking us on part B to calculate and then write the final reduced fraction or integer with the appropriate units. So you're going to need to write it as this one or this one, and I really like this one, but you pick. If you haven't hit pause in a while, this is a great time for you to go ahead and do parts C and D on number 4, and then come back and work with these with me. But looking at part C, it asks us to write the points in the second and fifth columns as ordered pairs. So here's the second column, here's the fifth column, and as an ordered pair, we still are dealing with x, y. So here's x, y, and this one's going to be x, y. And it asks us on part D to calculate the slope using these second and fifth columns. Leave your final answer as a reduced fraction or an integer with the appropriate units. I've erased the work from the last slope, but as a reminder, the slope we got on part B was 7 yards for every 1 second, and that was using the first and the fourth columns. So now we're going to look at the second and fifth columns, and I'll label x1, y1, x2, y2, and here we go. So 285 minus 180, 40 minus 25, and this looks very familiar in that when we divide, we get 7 again. 7 yards for every 1 second. And it should have happened this way, that with our slopes being the same, we have points that are on the same line. This concludes our lesson 8B, and you need to look at your calendar and your syllabus calendar, and if you have more lessons to do, then do those, and if not, upload these into D2L, and I'll see you next week.